All right, so on Friday, we started to learn about sedimentary rocks. We filled in page 25, which is the sedimentary rock chart, just like we filled in the igneous one. And this rock chart works the same way as the igneous one and the mineral chart. So it's just a dichotomous key, which you're going to work through to identify the 2, 4, 5, 6, 7, 8, 9, 10 sedimentary rocks that they have on the chart. If you remember, in fact, let me ask you, if I said, how are sedimentary rocks classified? Can you tell me? We start with texture. So if I handed you a box of 5 rocks and said, here, put these in groups, the first group you would make would be based on their texture, whether they're clastic, crystalline, or bioplastic. That's the first thing. But we're going to move on. So if you could flip over to page 26. Now we're going to break these groups down even more. So page 26, you're going to see that we're going to break the clastic group down, then the crystalline, and then the bioplastic. So I'm going to switch my screen for you here. Where are we? Switch my screen. How do I do this? You'd think it was my first day. Right behind the screen. Share screen, rocks and minerals, share, PowerPoint. There we go, but I want to go way up here. So we take the classic rocks, and to figure this out, everybody get your reference table out. Open it up to page 7. So now we're going to work on, so we already broke them into 3 groups. We got a crystalline pile, a plastic pile, and a bioplastic pile. But we're going to start with just the plastic ones. So I have a pile of 5 rocks, and they're all plastic. I want to separate them even further into groups. Please don't shout anything out. If I have a pile of plastic rocks, what is the next thing I'm going to look at to separate that pile of plastic rocks? Take a look at your reference table and point to the next thing we're going to separate the pile of plastic rocks into. So we're just doing plastic rocks first. We're on page 7 of your reference table, and how are we separating plastic rocks? So just point so I can just see, how are we going to separate plastic? Good. How are we separating plastic? Yeah, you got it. Good, good. How are we going to take just this group and separate them up? Just that plastic group. So just these 5 rocks. How are we going to do it? Perfect. 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 What do you want to do? We got just the plastic rocks. How are we going to separate just those? Have these 5 rocks, and I say, here, put these into piles. Oh. What are we going to do? You're into it back there. Yeah, there you go. And where are we going? All right, most of you got it. The plastic rocks. So we got a pile of rocks that we know are all plastic. By the way, what does it mean to be plastic? Made up of pieces, made up of fragments. So we got all these plastic rocks. The next thing we're going to look at is their grain size. Conglomerate and breccia, they're made up of pebbles, cobbles, and boulders embedded in sand, silt, and clay. Sandstone is made out of just sand. Siltstone is made out of just silt, and shale is made out of just clay. So for the plastic rocks, grain size is the next most important thing. These rocks are formed by deposition, burial, and compaction of sediments. We're on page 26, if anybody else isn't sure. Yeah, I kind of jumped around. We started at 25 and moved to 26. And the examples right off the reference table. Whoops, sorry, I'll go back. There you go. What is going on over here? So clastic rocks, again, they're the ones made up of sediments, crystalline, they're not made here. All right, let's look at the next group. We're gonna look at crystalline. Everybody go back to, we're gonna do the same thing, but now we're only talking about that little group of crystalline rocks. There's only 3 of them. How did they get separated? I hand you a pile of rocks made with crystal. These, are they grain size? They're not. How do I know it's not grain size that's important here? Wait, they're not divided. All 3 of the crystalline rocks have the same size crystals or the same size of grains. So grain size is not important for crystalline rocks. Did everybody get this page for plastic? Hang on. Kelvin will sharpen his pencil. All right, ready? Here is the crystalline. Now we only care about composition. Here again, their grain size does not matter because they're all the same grain size of crystalline. So when you have a pile of crystalline rocks, the only important thing for them is their composition. In the comment section, it actually tells you how they're formed. It says they are crystals from chemical precipitates and evaporites. So go ahead and write that and I'll tell you what it means. Might as well put the 3 examples up there now too. That was my ankle. I'm an old lady, what can I say? So I said these are formed from crystals that are from chemical precipitates and evaporites. You don't really need to know what this is, but just so it makes sense to you. So chemical precipitate means when you take 2 chemicals and mix them together, sometimes a solid will form. So basically this is chemistry. If anybody goes on to Regents chemistry next year, sometimes when you take 2 liquids and mix them together, a chemical reaction will happen and a solid will form and it'll float to the bottom of that container. So in oceans and lakes, the acid will sometimes make a solid in the water. And now evaporate's kind of the opposite of that. And that one might make more sense to you. So imagine you have a bowl of salt water. What happens if you leave that bowl of salt water out for a while? What will evaporate?
So
Just the water, actually. Just the water evaporates and it'll actually leave behind crystals of salt. That's how salt mines were formed. Over in Geneseo, there is a giant salt mine. over in that general area. I don't know if it's actually Geneseo. There's a giant salt mine there. And what that means is at one point, Geneseo was covered with salty water and the water evaporated and left behind a pile of salt right there in Geneseo. Over by Letchworth, in that general area. I think so. Okay, yes, Michael says it's east. All right, and lastly, we have bioclastic. Take a look at your two bioclastic rocks on your reference table, the bioclastic. What are they put into their two groups by? I heard it. These ones are put into groups by their composition again. So there's actually two different groups here. The first group is formed from cemented shell fragments. So basically a bunch of little things that have some shells will die in the ocean and the shells will sink to the bottom of the ocean where they will get compacted and cemented together, oceans and lakes and things like that. The other one, which is a type of coal, forms when plants, lots of plants, specifically tropical plants, the plant remains get laid down on the bottom of the jungle and eventually they get compacted together and we turn into coal. So make sure you get all of these onto the chart on page 26. I am, yep. So at the bottom of page 26, there's a few things you got to know about sedimentary rocks. And the first part is that sedimentary rocks are formed in layers on the Earth's surface. Do you need me to go back, Shelby? Yeah. Right. Here, 1 second, guys. I'm just going back. Anybody else need more time here?
No, I'm okay.
A couple of people still writing, so. All right, so now moving on. They form in horizontal layers on the Earth's surface. Guys, remember the Earth's surface includes the bottom of oceans. That's still considered the surface. It's not inside the Earth, it's on the surface of the Earth.
So on the bottom, is that where I'm writing?
Yeah, where it says formed in, right? It says formed. Now you add in horizontal layers on Earth's surface.
But do I put the on our surface where it says on?
Yes. Yep. Sorry to make that confusing, I guess. So you're writing the underlined words. So formed is already there. You're going to add in horizontal layers. And then the on was already there. So you're going to do on Earth's surface. Sorry about that.
I was writing with my pen close to my face. My pen kept doing that stuff.
Okay. I'm sure you can take it out.
I think that was very cool though.
Okay, cool. What? Oh, yeah, super glue. All over her face and her hair. Long story, which we don't have time to talk about right now, but yeah, yeah.
I birthday party before I had slime and it dumped on my head with that stuff.
Yeah, that's why slime is now outlawed.
So why?
Okay, so why does it happen on the surface? That's the next part. I didn't get to.
That's where all the weather and erosion and biological.
Right, so we gotta break the rocks into pieces. That can't happen unless you have the weathering and erosion to do it, and that happens on the surface. You can't have living things unless there's living things there. And the only place you'll find living things are on the surface of the Earth. So do you have both of these bullets in your packet?
Yes.
You do? Okay, not quite yet, everybody yet. No. I won't ask again. No. The next bullet, question number, or statement number 2 says fossils are almost exclusively found. Which layer do you think they are, since that's what we're talking about? Or which kind of rock? Sedimentary. Fossils are almost exclusively found in sedimentary.
Oh.
But let's talk about why. So I didn't change the slide yet because I don't want to give it away. So, but you can fill in that next one. Number 2, fossils are almost exclusively found in sedimentary rocks. Fill that in. And let's talk about why. Why do you think we can only find fossils in these rocks? Everybody think about this for a second.
Because the other rocks are too hard.
Because the other rocks are too hard? What, are
Yeah,
sedimentary
one
rocks
thing.
not as hard?
They're
They're not? So if I threw a sedimentary rock at you, it's not gonna knock you out?
Sedimentary ones are on land.
Oh, not just land,
They're surface.
but on the earth's surface. Where do igneous rocks form, or at least some of them?
Inside the earth.
Inside the earth. And where do we have lots of heat and pressure for metamorphic rocks to form?
Inside the earth.
Inside the earth. So how come there's no fossils then?
Because that's heat pressure will break them.
Okay, that's one, but that's not what you were talking about to begin with. So you said they're on the surface. Let's focus on that. So igneous rocks and metamorphic rocks don't always form on the surface. So why does that mean there won't be a fossil in them?
Because it's the-
Everybody think, because he's on to something here. He said that sedimentary rocks form on the surface. So why, they're the only ones that always form on the surface. So why are sedimentary rocks the ones that have fossils? Because they form on the surface.
Because they.
Everybody think, not just Anthony. I think Anthony stunk out.
Because they're from like pieces of dirt and.
They're talking to him.
Okay, so, come on guys, you guys can think too. Sedimentary rocks are on the surface. So why are they the ones that have fossils in them? What? Because the living things are on the surface. What are fossils made out of? Okay, plants, animals, they live on the surface. They don't live deep underground where rocks, other rock types are made. That's one point, but Anthony started to talk about another thing. What? We got metamorphic rocks that form from heat and pressure. So even if you did have a fossil in that rock and it got a bunch of heat and pressure, what's going to happen to it? Okay, it's gonna bust all up is really what's gonna happen. So even if you had a fossil and it got lots of heat and pressure, it's gonna get ruined. And let's say with an igneous rock, even if a dinosaur did fall into a volcano, why doesn't it make a fossil? Because it's gonna burn up. So basically, so this next bullet, there's a lot here, sorry. But you only have to write the underline. You already wrote sedimentary, I think. Fossils are exclusively found in sedimentary rocks. And the second bullet, because the formation of the other rock types would destroy them. Igneous, the hot lava would melt the fossil, and metamorphic would alter or destroy the fossil. That is an awesome goal. That's a cool goal. This last bullet, this is officially number 3 there. Fossils provide evidence of past environments. Add that bullet in too. What I mean by that, imagine you're digging in your backyard and you find a fossil of a fish. What does that tell you about what your backyard used to be, Riley? a lake or something, or water.
Ocean.
An ocean, or like, there used to be water. We would call that officially a marine environment. Marine, like the Marines who deal with water stuff sometimes, or marine biologists, the people who study water animals, or submarine, they go underwater. So a marine environment means there used to be water there. Imagine you found a fossil of a polar bear. What would that tell you? Used to be cold. Imagine if you found a fossil of a palm tree, Riley. Used to be warm and tropical. Thank you, Riley. So those fossils are important. So now you know the basics of sedimentary rocks. Now I want to make sure you can use that rock chart that we started to learn on Friday. Page 7 of your reference table. We're going to go right ahead and start your homework. I know we got about 20 minutes. That's a lot longer than I would usually give you to end the class. So it's not a request. I'm demanding you start your homework. And I'm going to walk through some of it with you so that you can know what's going on. Yes, is it important to what we're doing right now? No. All right, so what I want you to do, again, we're going to page 27. And yes, this whole page, every one of these blanks will be filled in for homework tonight. But let's do some of them together because I want to make sure you know how to do these. Now, if you're going to choose to go ahead without me, don't ask me questions that I already went over in a minute. So if you could just spend the next couple of minutes working with me, then you'll know what's going on. So I already did conglomerate for you. Let's go ahead and do breccia. Everyone find breccia or breccia, depending on how you want to pronounce it. Right there at the top of page 7. I first ask for the grain size and I want the name, and then I want it in centimeters. So breccia, what is the grain size? What are the name of the sediments that it makes? So pebbles, there's not a lot of room to write, so I'm going to abbreviate. Cobbles, boulders, sand, silt, and clay. Or if you can just want to write that mixed like I had in there, that works too. And now I wrote grain size. Again, I wanted the numbers, but they don't give it to us for pebbles, cobbles, and boulders on this page. Where will we find the size of pebbles, cobbles, and boulders? We did this on Friday. If you flip your reference table over right here to this one, page 6, it does tell you how big pebbles, cobbles, and boulders are. So since breccia is made out of all of them, we're just going to go ahead and write this variable there. And then you can fill in the comments right on your own for breccia, but let's do one more in that section together. It's the comment section. Oh, so what is the comment for breccia? Angular fragments. Not as many as I should. Let's do one more together. Sandstone. What's the name of the grain size that sandstone's made up of? Sand. And again, I'm not just making this up. You find sandstone, you go over to the word sand, and you can see right there, it's 0.006 to 0.2 centimeters. And in the comment section, it just says fine to coarse. So that top section's pretty easy. The middle section's very easy. Just copy it right off the reference table. I want to make sure you can read. Let's go down to C to make sure you know how to do C. On this one, you're going to be using ESRT, page 6. And they give you a grain size and you need to tell me if that's clay, sand, or clay, silt, sand, pebbles, cobbles, or boulder, and then what rock that will make. So I already did the first one for you, but the next one is 0.1. If you find 0.1 on this reference table, so there's 0.1, follow that over, that puts you in sand. So this one is sand, and then when you flip it over, sand makes sandstone. So you still have about 15 minutes to fill in the rest of this chart. You should be able to be finished or get really close. Whatever you don't finish on page 27 is homework.